Hey guys, welcome to section 4, chapter 8 of the geometry program. And in this section, we're going to focus on the similarity in right triangles. And the first thing that we find is something called the geometric mean. So proportions in which the means are equal occur frequently in geometry. For any two positive numbers a and b, the geometric mean is written like this. A is to x is equal to x over b. And then in order to solve for x, we simply do our cross products. Same thing that we've been doing. So x squared would equal ab, and x is simply the square root of the product of a and b. So when asked to find the geometric mean given two numbers, we can put those two numbers in for a and b, use our cross products and solve. So x squared would equal 256, and the square root of 256 is 16. All right, if you notice though, basically the formula is simply x equals the square root of a and b. So instead of writing this initial step, which you're welcome to do, if you're ready, you could just go ahead and skip ahead to plugging a and b in here. So in this case, I would solve for x by putting in 6 times 30. And now I'm going to get the square root of 180. But like all things, we need to simplify this radical. 180 is not a perfect square, so we need to break it down. Again, just like we've been doing. And again, I might use 6 and 30, and this would be 2 and 3. This would be 5 and 6, and then 2 and 3. All right, and then you're looking for prime partners. So 2 has a partner, he gets pulled outside. 3 has a partner, he gets pulled outside. But our prime 5 does not have a partner, he's got to stay underneath. So when we multiply these two together, we get 6 root 5. As a quick check, I don't know if you guys know this, when you've simplified, if you take the outside number and square it, and then multiply it times the inside number, you should get your original number of 180. So if I take 6 squared, I get 36. And if I multiply times 5, I get 180, which is what I was breaking down. That's just kind of like a short, quick fix if you want to check your work. Okay, so geometric mean is super easy. Multiply the numbers and take the square root, and then make sure you're just simplifying your radicals. All right, let's use another theorem here, theorem 8.3, which says the altitude of a right triangle divides the triangle into two triangles that are not only similar to the original triangle, but they're similar to each other. And that means that we can set up corresponding sides and solve for unknowns. Now, for those of you who are spatial, you might be able to orient the triangles in their existing picture, but there are a lot of students who are not spatial and they struggle to line up corresponding parts. So the way that I'm going to teach this section is I'm going to pull out the 3 triangles, the small, the medium, and the large, and then identify corresponding sides in order to set up our proportion. If you can see the corresponding sides without setting up the triangles, then you're welcome to just jump to the proportion part, but a lot of students struggle. So I'm going to go ahead and teach this part. All right, so here is the smallest of the triangles, and I'm going to pull him out first. And then the sides that I know are the base here at 5 and the height at 10. My right angle is my orientation. So as long as I can identify the right triangle. All right, and now for our medium triangle, this guy right here, again, our right angle is here, making our base 10 and our height x. And actually, we only need those 2 triangles to set up the proportion, but just so that you can see the large triangle then, that's the one on the outside, and it simply has a hypotenuse of x plus 5. So that's actually not going to be very helpful to us. But then in order to solve for x, I'm going to use the same thing that we've been doing. So you set up a proportion using corresponding parts. So now I have triangle 1 here and triangle 2, where we both have a height and a base that we can put into our proportion. So 10 is to x as 5 is to 10. So those are corresponding parts. And then we cross multiply. 5x equals 100 and x equals 20. So once you set up your triangles and you can see the pieces that go together, hopefully the rest is easy. It's just pulling those triangles out that can be tricky. All right, so let's do another one. So again, we have 3 triangles, small, medium, and large. So I'm going to start with the small. And again, I orient myself with this right triangle here. And in this small one, I have this base, which I actually know, it's not written, but I know what it is because I know the entire length here is 40. And I know the shorter side is 30, which means this very short side has to be 10. Okay, so let's go ahead. If you can like pull out information like that, that'll be helpful to you. So your base is 10, and then your height of this triangle is x. We don't know the hypotenuse. Now let's do the medium triangle, and that's the guy, he's always on his side. And our base is x, and our height is 30. And again, now we're not going to need our very big triangle, but we can go ahead and label it if we want. We simply know the hypotenuse here is 40. All right, but I have 2 triangles, 1 and 2, the small and the medium, where we have the pieces for both the height and the base, so we can set up our proportions. So again, it's corresponding side to corresponding side. So x is to 30 as the base 10 is to the base x. And now we can cross multiply. So x squared is going to equal 300. And x is going to equal the square root of 300, which is not a perfect square. So now we need to do a little bit of simplifying. So we can grab any 2 numbers that multiply to 300. I'll grab 30 and 10. And then I can break down to 5 and 6, and then 2 and 3. Break down my 10 to 5 and 2. And now I'm looking for pairs to pull out, prime pairs. So 2 has a partner, he's prime. 3 does not, but 5 does. 5 has a partner and he can pull out. And then 3 is the lone prime that does not have a partner. And so we should get x equals 10 root 3. And again, if you use my trick from before, take the number on the outside and square it. 10 squared is 100 times the number inside, which is 3. Should give you your starting number of 300. So that's like a quick check for you. All right, let's do one more, and then I think you guys will probably be ready. I hope so. All right, so again, we're solving for x here. We have 3 triangles. Let's identify them. Here's our right angle, meaning 3 is my base, and x is my hypotenuse. Look at this. X is opposite the 90. Okay. And then we have our medium triangle. And that's this guy right here. And all we know about him is our height, which is 24. And then let's look at our large triangle. Now we actually get to use our large triangle. This is the outside guy. And again, if you look at the right angle and how to orient yourself, we have the base of x, and we have a length of 24 plus 3, which is 27, right? We want the whole thing. All right, so now in this one, these are the 2 triangles that we need to set up the proportion. This middle guy doesn't really help us much. All right, so we're going to have a corresponding side of 3 to the corresponding base over here of x. And then the corresponding hypotenuse of x is to 27. And now we're going to cross multiply. X squared equals 3 times 27, which is 81. And x equals 9. So for some of these, you're going to get answers as integers, and some of them you're going to have to simplify. You're well versed in that now. We've been practicing a lot, so you should be good. All right, when you're ready, finish up your notes, read through the examples, and begin your assignment.